Test bench development. A test bench is a simulation environment that provides input stimuli to the circuit and captures its outputs for verification. It typically includes input generators that generate various input patterns, output checkers verify the correctness of the circuit's outputs, monitoring and logging, capture and record relevant data for analysis, challenges and best practices. Coverage. Test coverage ensure that the test bench adequately covers all possible input combinations and output conditions. Fault detection. Develop test patterns that can effectively detect common faults within the circuit. Timing analysis. Accurately model the circuit's timing characteristics and identify potential timing violations. Test bench efficiency. Optimize the test bench for performance and efficiency. Automate testing process to improve productivity and reduce human error. By following these guidelines and employing effective testing techniques, you can ensure the quality and reliability of your logic circuits. Fault models. A foundation for fault testing. Fault models are mathematical representation of potential defects or failures that can occur in a digital circuit. They provide a framework for designing test patterns to detect and isolate faults. Common fault models. 1. Stuck at fault assumes that a single input or output line is permanently stuck at a fixed value 0 or 1. Single stuck at fault. A single line is stuck. Multiple stuck at fault. Multiple lines are stuck. Bridging fault assumes that bridging fault assumes that two or more lines are unintentionally connected, causing their values to be the same. And bridging fault. The connected lines are logically ANDed. Or bridging fault, the connected lines are logically ORed. 3. Delay fault assumes that a delay element within the circuit is faulty, causing timing issues. A delay fault, a delay in a logic gate. Path delay fault, a delay in a signal path. 4. Transition fault assumes that a transition between logic value 0 to 1 or 1 to 0 is faulty. 5. Short circuit fault assumes that a short circuit exists between two nodes within the circuit. Fault modeling techniques. 1. Problematic fault modeling assigns probabilities to different fault types based on historical data or assumptions. 2. Statistical fault modeling uses statistical methods to analyze fault data and identify common fault patterns. 3. Physical fault modeling model faults based on physical defects in the circuit, such as open circuits, short circuits, or manufacturing defects.